Morning friends, today I am discussing about the most important chapter mensuration in class 9 and 10th. The previous class we discussed the circle, cylinder, cube, cuboid, but in this class we learn about the sphere, spherical shell and frustum. Today I am discussing about what is the sphere. When a circle rotates about any of its diameter is known as the sphere. For example, I have two things. This is the ball and this is the bangle. The difference between the ball and the bangle, here this is the sphere and this is the circular. If a circle, this means bangle, rotate about, from here, rotate about its diameter this much. This is the shape of a sphere. Again, so here this is the circle. If we rotate the circle about its diameter, this shape is formed the sphere. This means any circle rotate about the diameter. Here you see in this figure, this is the circle. If we rotate about the upward and downward position, and this is, suppose here N, S, east or west. If we rotate north to south, this is also formed as a sphere. If we rotate west to east, it also formed a sphere. So we can reduce a definition. If a circular lamina, or lamina means circular disc, a circular lamina revolve about any of its diameters. If a circular lamina rotate about any of its diameter, it is called a sphere. The circle is two-dimensional shape, but the sphere is a solid shape. That is, we also can written as here a solid shape which is formed by the rotate about the circular in any diameter. That is, when a circle rotate about its diameter, form the solid shape which is known as a sphere. The center and the radius of circle. The center and the radius of circle are called respectively the center and radius of the sphere. This is the center of the circle. So this is the center of a sphere. That is, this is the center of a sphere. Suppose the radius of circle is r. So radius of a sphere is also r, and the radius of a sphere is also r. This is the C, this is C, and this is C. So the center and the radius of a circle, respectively the center and the radius of a sphere. Now, volume of a sphere. By the conclusion, we find that the volume of a sphere is 4/3 pi r cube, and the surface area of a sphere is 4 pi r square. Pi r square, circular area. If rotate about its diameter, then it is 4 pi r square. So the volume of a sphere is 4/3 pi r cube, a square unit. This is a square, cube unit, and this is a square unit. So remember these two formula: volume of a sphere 4/3 pi r cube, and the surface area of a sphere is 4 pi r square. Again, next is a spherical sail. The solid enclosed between the two concentric sphere is called a spherical sail. This is the figure. Here, the solids enclosed by two concentric sphere. Suppose the cover of an egg is like as the spherical sail. Not a spherical, but it is seen as like a sphere. And the outer cover of orange is also as like as the sail. So the two concentric sphere, assume that here the two concentric sphere, suppose this is a sphere and inner sphere, and this is the outer sphere. Two sphere here. If the radius of inner sphere is r and the outer sphere is capital R, so the volume of a spherical sail is equal to 4 by 3 pi rq minus rq cube unit. This is known as the volume of a spherical sail. So the volume of a spherical sail is 4 by 3 pi rq minus rq, where r is the radius of external sphere and r is the radius of internal sphere. Both has the same center, so it is the concentric sphere. Now the next is hemisphere. It is the hemisphere. When a plane through the center of a sphere cuts it, that means this is the sphere. When a plane, suppose this is the plane, cut this sphere into two equal parts. Each part, suppose this plane cut this sphere through the center of the sphere, cut into two equal parts. This is the half part and this is the upper part. This is lower half and this is the upper part. So two equal part. Each part is known as hemisphere. Definition is when a plane cuts the sphere through the center of a sphere into two equal parts is known as hemisphere. Obviously, the volume of the hemisphere is the half of the sphere. So the volume of a sphere is 4 by 3 pi rq. 4 by 3 pi rq divided by 2. This is 2 by 3 pi rq. Is the volume of hemisphere. And the curved surface area, that is the CSA of hemisphere, is half of the sphere. So the curved surface area of a sphere is 4 pi r square. Here this is the half. So the CSA of hemisphere is 2 pi r square. Now the TSA, total surface area. Total surface area of hemisphere, 2 pi r square plus this area, that is the upper area. This is also a circle. So this is 2 pi r square and this is pi r square. So 2 pi r square plus pi r square. 2 pi r square plus pi r square. This is 3 pi r square. The hemisphere's TSA, that is total surface area of hemisphere, is 3 pi r square. 3 pi r square. And curved surface area is 2 pi r square and the volume is 2 by 3 pi r cube. The next we discuss about the frustum. What is the frustum? So I don't visit frustum. This topic. If a cone is cut by a plane, if a cone cut by a plane parallel to the base of the cone, parallel to the base of the cone, then the portion between the plane and base, suppose this is the cone VAB cut by a plane CD. Suppose CD is a plane cut by a plane CD which is parallel to the base AB, parallel to the base AB. Then the portion between the plane and the base, plane and the base, suppose VAB is a cone cut by a plane CD, so that this is the vertex of the cone cut by a plane. So the portion between the plane and the base, the shape is this much, is known as the frustum. Suppose this is the capital R and this is the small r. So in this case R is less than R. Suppose that this is the radius, small radius, and this is the capital R radius. So R is less than R. By the definition, we conclude that a frustum is the part of a cone. A frustum is the part of a cone. That is, when a cone is cut by a plane, by the parallel of its base, is known as frustum. Now discuss what is its volume, what is its surface area. It is the volume of frustum. Now we take a frustum, that is the part of a cone. So we draw a figure of cone. Suppose VAB is a cone cut by a plane CD, cut by a plane CD which is parallel to the base. So ABCD is frustum. Now we find the volume of the frustum ABCD. First of all, we take the height of OP, that is the height of frustum is h. Let us suppose that the height of cone by which this frustum is taken out be h1. So the height of the cone, that is VP is equal to h1. So VP equal to h1 and OP equal to h. So in this figure, this is right circular cone. This is the two circle here, triangle here. This is two circular part and forms two triangle POD and VPB. In this case, we solve here. There are two triangles BOD and VPB is similar by a similarity. These two triangles are similar, so we know that the criteria of similar triangle, the side is proportion. So VO by VP is equal to OD by PB. Now taking here the value of VO and VP. VO, the value of VO is equal to the H1 minus H, H1 minus H, and VP is H1. OD is equal to R. OD is equal to R. Here this is R, and PB, that is BP or PB is equal to R. So put here, and H1 minus H by H1 is equal to R by R. Separate here, H1 by H1 is 1 minus H by H1 is equal to R by R. So 1 minus H by H1 is equal to R by R. This implies 1 taken here, and this is H by H1 is equal to 1 minus R by R. Taking LCM as R, this is R minus R by R. So H by H1 equal to R minus R by R. Therefore H1 is equal to H into R by R minus R. H into R by R minus R. This is first equation. Therefore H1 minus H is also equal to HR by R minus R. Here value of H1 HR by R minus H. We take minus H and found out this result. So these two value H minus H equal to HR by R minus R, and this value H1 equal to HR by R minus R. We introduce the formula of volume of frustum. Now volume of frustum is equal to volume of VAB minus volume of VCD. VAB and VCD is taken out from the VAB, then we have the frustum ABCD. So the volume of frustum ABCD is equal to the volume of VAB minus volume of VCD. Therefore volume of VAB, we know that the volume of cone equal to 1 by 3 pi R square H. Here 1 by 3 pi R is R and H is H1. So 1 by 3 pi R square H1 minus 1 by 3 pi R square H1 minus H, because volume of VCD is equal to 1 by 3 pi R square H. Here H of VCD. This means H1 minus H. So written here 1 by 3 pi R square H1 minus H. Taking out 1 by 3 in the both volume, and pi also when taken out 1 by 3 pi as common, R square H1 remaining here, and here R square H1 minus H. Right here. This is, suppose this middle bracket, and the value of H1 is equal to HR by R minus R, and H1 minus H is HR by 1 R minus R. Putting the value here, 1 by 3 pi R square is R square, H1 is equal to HR by R minus R. Here R square is R square, and H1 minus H is equal to HR by R minus R. So H and H also present here, so H is taken out. 1 by 3 pi H common. Here R square into R is R cube, and R square into R cube by R minus R LCM. In both the cases R cube minus R cube by R minus R. This is AQ minus BQ. AQ minus BQ taken formula A minus B into A square plus AB plus B square, and A minus B is cancelled here. So 1 by 3 pi H and R square plus HR. This is the volume of frustum. Now we write here the curved surface area and total surface area of frustum. So write here curved surface area and total surface area. Please write down it. CSA curved surface area of frustum is pi L R plus R, where L square equal to H square plus R minus R square. and the TSA, total surface area of the frustum, that is including this and this. So pi r square plus pi, plus L r plus r, that is this is pi bracket r square plus L r plus r, where L square equal to h square plus r minus r square. So this is the total surface area of frustum. Now the next classes we discuss about some problem. What problem? Based on the volume surface area of solid shapes. Thank you for watching.